So the unit circle, the base of it is the radius is 1 unit. So if we put this on a coordinate plane and we draw a circle with a radius of 1 unit, we can put the points where the circle is on the graph. So right here, we go over 1 unit, radius of 1. So we have a coordinate point of 1, 0. If we go up, 0, 1. And we can do it on all 4 sides. So using the circle, we can come up with the points on the circle. Now the harder part is, what if we go over here at 45 degrees? What is the x and y coordinate here? Now, knowing that it's 45 degrees, we could type in cos 45 and get the exact value. We can do it for sine. Same thing. But the thing about the unit circle is we don't use decimals, we don't round, it has to be an exact value. So at this point, it's root 2 over 2. Now, you might ask, where did that number come from? If you put this into your calculator, root 2 divided by 2, you will get the same number with 9 decimal places. But this is the exact value of the x and y coordinate at 45 degrees. Again, the radius is 1, the x is root 2 over 2, the y is root 2 over 2. So here's how it works and how we figured this exact value out. So what I've done is I've created a triangle from the edge of the circle, the radius is 1, and the triangle. So the y value is the opposite, the x value is the adjacent. Now, I don't know what these are, but I know that they're exactly the same. So what I'm going to do is I'm going to replace y with x. They're the same length, and I can use Pythagoras to calculate it. So at this point, I need to use algebra. I'm going to work backwards, and I'm going to use SAMDEB. Anytime we do algebra, we're going to do BEDMAS backwards, SAMDEB. So I'm going to divide by 2, and then square root. So the problem with this one is we're not allowed radicals on bottom. So to get rid of it, we are going to multiply by 2, root 2, top and bottom. Square root of 1 is 1, so it becomes root 2 over 2. That's where we get it from. This is the exact value using Pythagoras, but the key thing is the radius is 1, the hypotenuse is 1. So if we know that, we can calculate the exact value. Now you don't need to memorize this, but it's good to know where it comes from and why we can get this exact value. So coming back to the unit circle, I've put in root 2 over 2 for both the x and y coordinate for 45 degrees. Now we already figured out 0 and 90. Now we're going to focus on the 30 and 60. And to do this, we're going to draw an equilateral triangle. So I've drawn an equilateral triangle, and I've put half of it above, half of it below. Equilateral, equal angles, they're all 60. But if we cut it down the middle, we end up with 30 on both sides. This is where we get our 30 and 60 degrees from. Now, the radius is 1. It's always 1 on the unit circle. And if it's equilateral, all 3 sides are 1. But I've cut the circle in half. So I get 1/2 and 1/2. So I'm going to focus on the top triangle. I've got 1, 1/2, and the x coordinate is unknown. The y coordinate is 1/2. Let's use Pythagoras for this one. So I get to this point, I'm going to use SAMDEB. I'm going to work backwards to move the number over, then square root. And at this point, I subtracted 1/4 to get 3/4, and then square rooted both sides, and I can square root 4. It's a perfect square. Square root of 3 divided by 2. So what that means is the x value of a 30-degree triangle is root 3 over 2. The y value is 1/2. And this works for any 30, 60, 90 degree triangle. So as we just learned that if I have a 30 degree triangle, the x-coordinate will be root 3 over 2 and up 1/2. So notice that they're all divided by 2. And pretty much we have a 1, a 2, and a 3. So they're pretty easy numbers to remember. They're all similar. If I go to 60 degrees, the x-coordinate is a small amount. It's 1/2. And the y-coordinate is near the top, root 3 over 2. So just take a look at the pattern. If I make little marks here, I'm going up in number, 1, 2, 3. The y-coordinate goes from 1/2, root 2 over 2, root 3 over 2. If I go on the x, the smallest one is 1/2, the medium one, root 2 over 2, the third one, root 3 over 2. If it's easier, think of it as a square root of 1, which is why that one doesn't have a square root sign. So that's the first quadrant. If you know these three, plus the easy 0, 1, 1, 0, you can use these numbers throughout the whole circle. So now that we've built the unit circle, how do we use it? So the first question we have is sine 45. We're not going to put it into a calculator. We're just going to look at our unit circle. Now, sine is the y-coordinate. So I'm going to go over to 45 degrees and find the y-coordinate, root 2 over 2. No decimals, exact values only. That's the benefit of the unit circle. So cos 60, go back to the unit circle. Cos of 60, cos is the x-coordinate. So the x-coordinate at 60 is 1/2. Another way to look at it is 60 is the first one along the x-axis. It's the smallest value of the three. And tan is the hardest one. Tan is y divided by x. So we have to look at the y-coordinate of 45 and take this one divided by this one. Now you can keep change flip the second fraction and simplify. Or root 2 over divided by root 2 is 1. 2 divided by 2 is 1. So tan 45 is just 1. Cos 30. Keep going back to your unit circle. 30 degrees is right here. Cos is the x-coordinate, root 3 over 2. Sine of 90. This one's a nice easy one. 90 degrees is up here. Sine is the y-coordinate, 1. And tan of 180, we haven't done anything past 90 yet, but basically 180 is over here. And the tan, the y-coordinate is 0. The x-coordinate is 1. So tan of 180 equals 0.